And we're live. Welcome back to another Corona Geek. Here where we talk all about cross-platform app development using Corona SDK. I'm your host, Charles McKeever, and we are on a modified holiday schedule here. We're kind of showing up in between is everybody in their jammies, first of all? Is this
Oh, no, sir.
that's not the
I got
jammy
my
show?
Full day of work ahead of me, my friend. Full day.
You got lots of work ahead of you.
Yes.
That's always the problem with the end of the year is like either I keep saying every year, next year I'm taking the end of the year off, and it never happens. So anyway, so thanks for being here. I appreciate it. So last week we finished up our what we would call it our desktop top-down shooter game series. We had 11 videos in the playlist, which you can find at youtube.com/coronageek. There's the source code is available on any one of the show notes. So if you check the link in the description, you'll find the show notes. You can go over there, and the link to the source code is all available. But that whole discussion really started out with keyboard and mouse support, and then at the end we kind of dropped in controller support. Right? So now we want to do a twin stick shooter. And is it fair to say that this will be more focused on controllers right from the beginning? Is that what we're saying?
It is going to be focused on controllers right from the beginning. It's an interesting question. I wasn't ready for it. Let me think for a minute. I'll answer you.
Well, that's okay. We're gonna do the twin stick shooter series. We're gonna start it off, and we're not gonna have a Corona Geek next Monday. So I just want to say that right up front. Today's episode is going to be sort of an introduction to the topic and what we're going to do and what we're going to cover, and then next week a lot of the Corona crew, a lot of the Perk crew is going to be in Vegas for an all hands event. So we won't have an official Corona Geek hangout like we do every week, but you can watch social media and there will be lots of pictures and video clips and things like that I can capture along the way. So apparently some of the things that happen in Vegas won't stay in Vegas. So
We'll make sure we get the right things staying in Vegas. That's all I'm saying.
Yeah,
All
exactly.
I gotta say, Charles.
Yeah, exactly. So there you go. So that's what we got going on. I did want to mention a few things from the blog before we get started. Last week we were so excited to kind of wrap things up with the top-down shooter series that I completely forgot to mention that there are some brand new things to play with over the holidays. So one of them is OS 10 is out of beta, is now officially, even though we don't use the 1.0, 2.0, dot release notation, it is officially out of beta and ready for production for prime time. So if you're interested in creating desktop applications, which that whole series that we did was a good primer for that, then you can do that with OS 10. 1.32 is hot on the heels, should be coming out soon, coming out of beta. There are some things that need to be, loose ends that need to be tied up before that, but we're hoping to get that out, probably the end of January, hopefully, of next year. So it's coming along pretty well. The other thing is that tvOS is now out of alpha. So if you were following along with that, kind of playing with it, it is now in beta, which essentially means if you're a brave soul, you can package up your app and submit it to the App Store when they reopen, of course. But that's out of alpha, now in beta, and there's also a new iCloud plugin. So before there were ways of storing data for iCloud, but we wanted to, with tvOS, we actually had to provide support for syncing between devices using iCloud, and now there is an official plugin for that, and you can. So basically, if you start your game on one device, then you can pick it up on another. And Rob's pinging me here on social media, so I'm gonna add him to the conversation. I forgot to send out the links to today's hangout. I was in a hurry, so apologize for that. If you're watching from the outside, like ding ding ding, tapping on the glass. As soon as you start talking about the twin stick shooter, I'll send out the email to everybody so they can.
Roger that.
Join us.
I'll cover the gap.
Yeah. So, but that's it. There's, like I said, there was those items that I wanted to mention. There's also a tutorial out there for using iCloud key value storage, which is kind of hot on the heels of the iCloud plugin bit. So if you're not familiar with iCloud, usage, and you want to kind of get into the sync of things, um, then that's a good place to go over and get started. There's also a tutorial on implementing cross-module functions and events, which Ed, I know you've talked about here on the show before, but there's an official tutorial on that if you want to walk through it. And what else? There was one other thing, it seems like. Oh, and there was one other blog post on understanding random numbers in Corona. So I saw that there was a forum post on random numbers, and Rob's put together an official tutorial on that you can go through. So lots of great stuff on the blog. If you haven't already, go over to chronolabs.com/blog, check it out. And if you have your questions, post them in the forums. Hey, we got Steven, I think. Is that Steven? Hey, Steven. All right. Any other things that we want to announce before we go? Anybody on the panel got any announcements?
Nada.
Okay. All right. Well, Ed, if you want to take us into twin stick shooters, I will try to invite everybody behind the scenes.
Okay then. I'm sharing my screen. You should be able to see it now. And so we already did one series. First of all, I apologize. Windows 10 has decided that this should be my default PDF browser for some reason. I just did an update, and it's reset all my settings. I love it. So I'm back to default settings. Anyways, Geometry Wars Retro Evolved is the game that I have selected to represent our twin stick shooter examination. Now, we did another game already, and we talked about desktop settings and maximizing screens and minimizing and dragging and all that good stuff that goes with a windowed or full screen game. And at the end of that, we inserted a discussion about gamepads and joysticks. But this time around, I want to really focus in on a game that represents the target. And so our target for this game is a twin stick shooter that also has some nice elements. Geometry Wars Retro Evolved came out, I believe, in I want to say like 96, but it could have been before. Anyways, I'm sure there's a wiki on it. It's quite an old game, but I have to say, when I first saw this game and played it, I thought, wow, that is, I used the horrible word simple. It's a simple game. Well, it's a simple game in the sense that they really tuned down the graphics and they use basic shapes, geometry, obviously. But having gone and started to implement a clone of this game, I came to the realization, as one often does, that there's a lot more going on underneath the hood than expected. This screenshot that you're seeing here is it's a perfect example of that, which is why I put it up first. I'll get to this in a minute, but one of the things that we're going to deal with is this game has a tremendous amount of stuff going on at one time, a tremendous number of objects on the screen. What you're seeing here is any typical moment of gameplay. Once you get past like 5 minutes, it's just chaos on the screen. There's particles flying everywhere and special effects going on in the background and a zillion enemies trying to kill you. I can't even find the player right now. I'm looking for it. I don't see him. He's in here, but lost. It's the kind of thing you can't even, actually, it's right here in the middle. You can't even see it unless the game is moving. So, okay, before I launch into the whole overview, what I'm going to do is give a quick overview of this game. But again, the focus is going to be on twin stick, so 2 joysticks working together, and a few buttons on the gamepad. And then what we'll do is, at the end of the game, I will quickly modify it to be mobile capable, and we will replace the joystick inputs with on-screen joysticks and some buttons, so that we'll be ready to do this on both mobile and desktop. Sort of backwards, I think, from where we started previously. Okay, so Geometry Wars Retro Evolved, and I'm going to give some links at the end of this discussion. But if you have not played this game, please go get it. You can get it on Windows. I'm pretty sure you can get it for OS 10. And if not, you can get it for mobile. So the goal of the game is very simple. Stay alive. You get 3 lives. You can acquire more as the game goes on. And if you lose them all, the game is over. Another goal, destroy enemies or avoid enemies. But pretty much you're going to have to kill them all, because if you don't destroy them, the game gets filled with more and more. And as I said, earn lives. So to keep yourself going, you need to earn more lives. And that's really all there is to the game. As far as the game logic goes, you start off with 3 lives. You can earn more lives, and everything is based on points. The more points you get, the more lives you earn, the more upgrades you get for your weapon, the more mines and other things that you get, and the more difficult the game gets. The game ends when you are out of lives. You earn points, as I said, for killing enemies. I'm reading my own notes here. And an interesting thing about this game, now, it's hard to see it without looking at the source code, but from playing it a number of times and examining it, what I think is going on here is there are no specific levels so much as the game gets more difficult as time progresses. So at 5 minutes in, it's pretty difficult, but at 10 minutes in, it's significantly more difficult. And this difficulty resets every time you die. So if you lose a life, for a few moments, the difficulty ramps way down, and then it sort of ramps back up again to where you were before you died, but it does it on a much more intense curve than from the beginning of the game. So let's say you've been playing it for 5 minutes and it's been gradually ramping up. Then you die. Then it gets easy for about 30 seconds, and then it quickly ramps back up to where you were at when you died previously. One thing that's worth noting is when you die, all of the on-screen enemies are removed, and that gives you a nice clear starting point. So all the enemies are destroyed, your player is respawned, and then the level starts to populate with enemies again. As I said, this is going to be a twin-stick shooter, which is going to be the left and right joysticks on a gamepad. And it will also involve at least one more button for dropping what I call mines, but I think they may be named something else in the wiki. And there's a wiki to go with this game for folks to read up more details about it. And as I said, at the end of the series, what we'll do is we'll reconnect the inputs to dual virtual joysticks on the screen. So this screenshot here is actually from a different version of this game. I think this is from the 3rd one in the series. But the concept is the same. They've done this for mobile, and you can see 2 circles on the screen. And these are virtual joysticks where you'd put your thumbs and treat it just like a normal joystick. Let's see. So the player, everything in this game is very simple graphically. And simple is not a good word. I really hate that word, but basic. So for my implementation, I'm going to be using basic shapes, just textures with no special artwork. And so the player, for example, will be an image we'll be using physics for movement and for collision. And it will be able to move in any direction based on the inputs from the left joystick. And I'll show you this in a minute. And it will be able to fire in any direction based on inputs from the right joystick. And this is what the player looks like. Unfortunately, I don't have any high-res images, so I just had to snap these out of gameplay and then post them up on the screen. This is one of those games that no matter how much I talk to it, you absolutely must go play it, so you have a firm grounding in what we're trying to achieve, and then you'll appreciate the challenges that we're facing in this series to get anywhere near the visual fidelity that they exhibit in the final finished game. This game has 7 enemy types, of which we will most certainly implement at least 3 of them. It has pinwheels. Pinwheels are the most basic enemies, which are shown here in the lower left corner. They are, in a sense, they're like our dumb green zombies from the last game. They just move towards your player. They're not really fast. They don't have any strategic elements to their intelligence. They just keep coming after you at a very slow pace. Diamonds. This little blue guy here is also shown. This is a diamond. Now, diamonds are similar to pinwheels, but they have this behavior that A, they move a little bit faster. B, they like to work in teams, so they gang up on you, whereas pinwheels are usually free-floating and they come one by one. Diamonds will generally be generated in groups of 1 to 3, perhaps more. Green squares are similar to diamonds, but they have an additional artificial intelligence capability. When you fire at them, they will dodge your bullets depending on the angle of attack. So if you directly fire at them, they don't dodge those bullets. But if you fire at an offset, they will dodge that shot. So you have to be extremely accurate when you're shooting at these, otherwise you'll miss them. Pink boxes, which I haven't shown here, as I didn't show the green squares. Pink boxes are sort of like diamonds, except that they move significantly faster, and when you destroy them, they spawn 2 more smaller diamonds, which then give chase. And different versions of the game, some versions they spawn 2, some they spawn 3. Then there's snakes, which I'll show in a minute. Snakes are what you would imagine. They're a headpiece with a tail, and their key feature is that touching any part of the snake kills you. But the only way to kill a snake is to shoot it in the head. Shooting the body doesn't do any damage to the snake. And the way they move around on the screen, their bodies are usually blocking the head, so you have to get really creative in your approach to these things so you can take them out. Jacks, to be honest, I'm not very good. I'm not very good at this game. I have not gotten so far as to encounter jacks. So personally, in my own gameplay, I've never gotten so far as to encounter them. But as I read about them, they are basically, again, like diamonds, but there are many, many, many of them, and they are very fast, and they will ambush you. And then finally, there are Pac-Men, which strangely enough I have encountered, which are very similar to your player. So here down in the bottom of the screen is a picture of your player, and off to the right is a Pac-Man. It's basically you, but the enemy. And they don't shoot at you, and they move like you, but they're a little bit slower in turning, and they have a shield in front of them. So you cannot destroy these things head on. You have to find a way to get behind them and shoot them that way, or you have to use one of the only other element in the game, which is the black holes, which I'll talk about in a moment. One thing we're going to do in this game is we'll talk about the AIs individually, and we're going to break them out into modules. So last time around, we had enemy creators for each enemy type, but this time what I want to do is have one unified enemy builder, and then I will insert, because the brain code, the thinking code for these is going to be a little bit longer than last time, I will separate out the brains for each one into individual modules, so it'll be very easy for people to look at them and to copy them and sort of like manipulate them and make modified versions of these, what I call brains. Let's see, spawning. Another thing about this game, besides the graphical intensity of it, that I haven't been able to figure out is their spawning methodology. Now, if you play this game, what you'll notice is that the spawning of enemies changes over time. It becomes what I would like to call strategic. The game knows where you're at. It sort of thinks ahead of where you're going to be, and it may place enemies in your path or someplace that is going to be really difficult for you to deal with. Like you're in a corner, and then you are suddenly surrounded by enemies both behind and in front. So it knows that you can't get away easily, so that's where it places them. But it has a bunch of other spawning features too. Unfortunately, unless I have a lot more time to play this game and observe it and break it down, I'm just going to have to stick with to what I call quadrant-based spawning. So in quadrant-based spawning, what will occur is the game will detect if you're in the upper left corner of the playfield, upper right corner, or lower left. And if you are in, for example, the upper left corner, it will be allowed to spawn enemies in any of the other 3 quadrants, somewhere randomly within the boundaries of those quadrants. And the reason I want to do it this way is, 1, it's easy to implement. 2, one of the things you have to be cautious about when you're spawning enemies in a game is not to spawn the enemy directly on top of the player. Meanwhile, you may also be following certain rules, like can't spawn enemies outside of the game board, etc., etc. So if we can define smaller portions of the game world or the board where it's okay to spawn enemies and mark them as can spawn here, then we've solved all of our problems. So, for example, again, upper left quadrant is off limits, but you've got 3 other quadrants where you could spawn an enemy. Choose one randomly, and then choose within the boundaries of that quadrant and spawn an enemy, and you know that it won't be on top of the player, it will still be in the game world, and it will be in a position to be, hopefully, somewhat challenging. Alright, so in addition to enemies, the game also has one obstacle, and that obstacle is a black hole, which is an object that appears at higher levels, and as soon as it is struck by your shooting at it, or I believe if an enemy runs into it, it activates. And as soon as it activates, it starts sucking everything nearby into it, just as you would imagine a black hole would. And black holes then last for a certain amount of time, and then they blow up. They're done. They destroy themselves. Additionally, you can shoot black holes to make reduce their lifetime. Now, I think in the game actually what it is if a black hole consumes a certain amount of material, it self-destructs. So shooting it is basically feeding material to it, and then enemies falling into it is also. So if you fall into it, you die. But this is a strategic element in the game, which I would really like to implement, because you can use it to protect yourself. And in fact, you'll find when you play the game for real that you will get black holes on the screen, and you'll purposely not activate them until you need them. And then you will ride the periphery of the area where you would get sucked in, and let the enemies come to you and then get sucked into the black hole. Let's see. Weapons. So the weapons in this game are really simple. You have a cannon, and I think I spelled that wrong. I think it's C-A-N-O-N, which starts off as a dual projectile. It shoots 2 bullets, and then as the game proceeds and you get more points, you will get weapon upgrades. Your weapon will get, every once in a while, you hit a certain point value, it will get faster, or you will get more bullets with a greater spread. And so I haven't decided on the schedule for when those things get put in as far as points go, but I'll come up with some random schedule and we'll implement it so that it's similar but not the same to the game. It's worth noting that every time your weapon gets upgraded, that upgrade only lasts for a few seconds, like maybe 10, and then it goes back to the cannon again. Now again, different versions of this game, releases on Xbox versus Windows, may behave a little bit differently. But that's what I've seen in the Windows version. The other weapon is a mine, and you get 3 of these to start with. And if you've ever played, what's that game, the side-scroller, Defender. So if you ever played the old retro arcade Defender game, you'll be familiar with the concept of a mine. A mine is a weapon that, when dropped, immediately detonates and destroys all enemies in the game world. So this is the weapon of last resort. This is when you are really up against the wall and it's too much, and you'll find yourself needing these almost immediately in the game, which is it's a good thing, I guess, but maybe it's a sad testament to my ability to play this game. That I quickly run out of mines and then wish I had about a dozen more. But you drop one, destroys all the enemies, and you get a small reprieve before enemies start showing up again on the screen. Camera. Initially, when you look at this game, you'll think, oh, the camera's pretty basic. But if you can, maybe you should watch the video and not play it. Then you'll actually be able to observe. They have a very subtle parallax going on in this game. So what's going on is they've got a 3, maybe 4 layer star field, and then the world is bounded by a neon box, and then there's a grid. And so as you're moving around, you'll see that the star field moves with parallax to give you the sense of depth, but it's real subtle. So that's one of the things I really liked about this game, is that everything they did was perfectly tuned to give you this overall really nice visual experience. So you're completely focused on the neon explosions and all the interactions, but there's a lot of subtle stuff going on in the background to give it extra depth. Another thing that is going on in the background is what I call a perturbable grid. And I should just show you this right away. Let me find it. Come hither.
Yeah, I'm not sure that I ever heard that term before, perturbable.
Well, they've got this grid. So let me show it to you, not perturbed, and you can see this grid, this blue grid in the background with a little ripply things going on here. And this grid responds to the motion of your ship and explosions and the black holes and certain things. I think it's supposed to, in a sense, be replicating the concept of energy and gravity releases. And so, for example, when you spawn, that's a huge event. And so all these ripples fly out from the spawn point across the grid. Now, I would really like to implement this, and actually I was talking to Steve, who is watching quietly, about a month or two ago, and he sent me a bit of code that got me started on this. But so far, all we've got is one ripple. What I would like to do is figure out how to do multiple ripple points within one image. And so hopefully by the end of the series, we'll be able to discuss this. This is going to be a shader topic. It'll be a one episode topic where we talk about how to use a shader if I manage it. I think we should at least do the single ripple. How to use a shader to give a ripple effect on a graphic and then or a background. Let's see. Let me get this. We're almost through this presentation here, and then I'll show you the game as it stands. The camera. Okay, so the camera is fixed. It tracks the player. It has no lag or anything like that, so it's constantly keeping the player in the middle of the screen. And as I said, the world is bounded. It's a bounded area. It's going to be slightly larger than the screen, and it has a strong neon border and a grid to show you just basically where the world is. The one I'm going to show you today doesn't have a star field yet, but it will by the time we start our discussion. One of the major challenges of this game is the special effects. Now, I think that they did a lot of close to the metal programming for this when they implemented it, because this came out on the first Xbox hardware, and yet it performs flawlessly, even though you can get thousands and thousands of particles on the screen at a time. So some of the kinds of effects that we're going to have to replicate are a radial explosion of particles, and so that's this one here, where when an enemy or your ship explodes, you get a burst of lines or very thin rectangles coming out in a radial pattern. And that this screen here in the middle shows you the chaos that can occur. And that first screenshot I showed, which is just like everything exploding and all these particles coming out, that's what all this is. Everything overlapping. But another major particle effect is the player trail. So the player leaves behind this trail of particles. Now, one thing that I'm not going to be doing initially is giving these things glow. So you'll notice that all of the effects in the game have glow, and until I solve the particles quantity issue, I don't want to deal with glow, because glow will in effect double the work for us as far as computing goes, and so I don't want to add more work on top of the fundamentals. And then there's grid perturbation, or what did I call it previously? Yeah, perturbable grid. And we will have to deal with that very late in the show, because I wish to get to all of the other elements first, and that involves me coding them up. So the only other thing I believe is yes, the only other element that we'll have to deal with in the game is the HUDs, or the well, I call them HUDs, the labels, the counters, and the things that you have are a score counter, a high score counter, and then you have an indicator for how many ships you have left or lives, and how many mines you have left. So these are very simple HUDs. It's a very elegant layout. It doesn't have anything else on the screen for the standard Windows version and the Xbox version. So lastly, because this is actually quite an intense game, we're going to have to deal with some optimizations. And so some of the optimizations that I am entertaining are caching, and two kinds of caching. Caching the results of heavy calculations. So some calculations, for example, the length of a vector or calculating a vector from an angle are costly, and you don't want to do those 5,000 times per frame. What you would like to do is calculate them once and then just reuse the values over and over. Sergey's asked a question, and I'll answer back in a minute. And the other kind of caching is, and I don't normally do this, but I've seen people talk about it a lot in the forums, so I will test it both ways and see if there's any benefit. Because we're producing a lot of objects that are going to be similar, one thing we could do is simply not destroy those objects when we're done using them, but cache them, put them somewhere off screen, and then when we need a new rectangle, for example, simply look in our bucket of rectangles and see if we have one we haven't used, and bring it back to where we need it, recolor it the way we need it, resize it the way we need it, and display it. And so this is object caching. Now, personally, I don't think this is going to buy us anything. Normally, people do object. Yeah, so it's a pool. Steven is right. It's an object pool. This for people who are watching the group chat. And the problem here that we're trying to solve when you cache an object is there's a cost to creating an object. Now, part of the cost of creating an object is memory allocation. Now, I may be misspeaking here, but in my experience, the major cost nowadays for modern computing is actually in the memory allocation. It's not in the other operations that go on once the object has been allocated. So, to be clear, you create a rectangle on the screen with an image in it. There are several steps here. One of the first steps is the game engine or the SDK needs to say, hey, operating system, I need some memory to store this information in. Give me the memory that I need. Now, the next step then would be to, let's say, tell that image, here's the buffer you're pointing to, here's the position, here's your alpha, etc., etc. The thing is memory allocation, depending on how it's handled, like I said, is very costly for CPUs today. Whereas all these operations, just changing little details in memory, are extremely quick. Memory access is slow. In the CPU and in the cache, very fast. So, backing up. When people say that they want to use pooling or a object pool, what they're doing is they're trying to amortize the cost of allocation. Do the allocation once, keep that thing in memory forever, and then just move it into view when you need it, and do those rapid operations like changing the position, changing the alpha, etc., etc. The thing is Corona SDK uses Lua to do its memory allocation, I believe. And on top of that, regardless, it uses a pooling mechanism already to allocate memory. So it grabs a block of memory and then starts to use that memory as it goes along. And then when it needs more, it grabs another block. It doesn't say, give me a little tiny segment, give me a little tiny segment. It says, give me a large block of memory, and then I will manage it myself. So the question that exists is the way that Lua/Corona is managing its own memory faster than me caching? If me caching an object is slower, then there's no point in doing it because I use a lot of memory that I may not need, and I'm not getting any benefit out of it. So I will experiment both ways, and I will give some benchmark results that I'll show to people, and we'll decide together, both on desktop and on mobile, because it may be different on mobile, if it's worth doing this. And I'm waving at the screen like I usually do, but you can't see me. So some of the other things that we'll talk about, perhaps, if we have time and if we feel like it's really worth it, is remapping inputs, which is basically modifying the inputs on the controller, although I really don't see that being useful because we really need joysticks, and the only thing we could remap would be the button, perhaps, for laying the mines, and if we use buttons for something else. Particle alternatives. If we cannot solve the particle problem, which is when we need to get thousands and thousands of particles on the screen, we may run into a problem where we simply can't get a performant result, especially on mobile. Having thousands and thousands of objects that all need to be moving and changing their color and their alpha and dealing with collisions and all that, it may be too much for mobile. So we may need to come up with an alternative approach. So once we get there, if we decide we need to come up with an alternative approach, I will provide one, and we'll talk about that. And then lastly, grid perturbation. I think at the very least we should cover a single ripple in the grid, and then if we can find a way to do multiple ripples, all the better. So this document that I've been talking to, kind of boringly I think, is going to be available in the download link for today's show, and at the very end of it you'll be able to find some links to the MobyGame listing, a wiki that talks about the game, and I'm pointing directly at the enemies link, but you can click this and then start over and read it from the beginning. And then a YouTube video, which if you don't want to buy the game or you can't find it somewhere to play it, then you can at least watch it. And I think it's a very good example of everything we've talked about.
So Ed, I have a question.
Sure.
I'm looking here on my phone, and I see Geometry Wars 3.
Yes.
Is that the same thing?
It's the same series. I should have mentioned that. Okay, so the Geometry Wars series, I think there's somewhere between 3 and 5 games. It really depends on how you count them. It all started with Geometry Wars Retro, which then became Geometry Wars Retro Evolved, which was the first one, I think, that was released on Xbox, and then later got released on Windows. And then there was Geometry Wars Retro Evolved 2, and then Geometry Wars 3, and there may be others. So yes, all part of the same family, but Geometry Wars 3, the one you're seeing, is played on a different world style. It's got a 3D-ish implementation. Yeah. You play around a pseudo-sphere. I did not want to address that one because it was way beyond what I wanted to try to code up for this.
Okay. So just for people who are looking at that, especially if you're looking at it on your iOS device, I mean that's it's a $10. That's a $9.99 app from Activision.
That's a no-nonsense app.
Yeah, and that's the Geometry Wars 3 Dimensions Evolved, so which is different than what you've been describing.
Yeah, no, you can get what I've been talking about like for $3 on Steam.
Okay.
Something like that. I think it's pretty cheap. Or wait for a sale. It goes on sale pretty often. Okay. So, what was I going to say? Oh, Sergey asked a question, and it sort of dovetailed with what you were saying. Yes, Sergey has said, is it going to be a new game or a modification of the last? It's going to be I'm going to take a lot of components from the last game and then reuse them. But it's also going to be quite new in the sense that I'm going to recover some of these aspects of like how to build the player, how to build the enemy, because I want to change the organization, especially with the enemies. The way I did it previously would not suit well to this. There'd be too much extra coding. I want to be as tight as possible on the coding, and so I'm changing things up. So it's going to be more new game than old. I always reuse parts, like the sound system for this one, which I didn't even talk about. That'll be reused. The camera code, reused. The layer development code for the rendering layers, reused. So there's large swaths of this that are going to be familiar that we won't need to go over again.
Okay. Yeah, but for the most part, a new game. So, I wanted to mention that I loaded up the previous game that you did, top-down shooter. I loaded it up on a mobile device, and it actually looks really great. You can't move, and you can't shoot, right? Because we don't do tap events.
That's the little part where you die right away. It looks great.
Yeah, but it does. I mean, seriously, it does. And I did bring up the. I think I brought up a controller. I got a controller for Christmas. The Steel series controllers, and which is what like an MFI controller or something. Anyway, and I was able to move around on the mobile device with the controller. So it's the elements are there, right? If you wanted to completely convert it into a mobile game, you could. Or if you wanted to, there were a few issues that I ran into with the controller piece, but I don't know if I was running the latest version of the source code. But anyway, enough. It's enough there to play with. So
Would you like me to do like a mini episode on a future show where I could simply add some buttons to that for the mobile version, and then show
that's
people where the code is, and then
that.
this goes up because you could easily add buttons into the structure as it is. Last time we talked about it, we had the keyboard mouse
Mhm.
control scheme and the controller. We could add a third one, which is mobile.
Yeah.
And
If
have
you
that
if
for
you
the
want to do that, I think that'd be great. I mean, it's like 99% there, right? It's
Yeah,
just the touch inputs aren't there, and um,
yeah. No, it's definitely reverse. That's why I definitely want to, on this one, I thought about that. I thought, last time we didn't push this one back to mobile. This time
right.
around, this game, totally suitable for mobile because you can easily create virtual joysticks for mobile. I mean, there's really not much to converting this game back except for like reducing the number of particles perhaps and some optimization stuff. But
Yeah.
get this thing working, controller working, change the input scheme, you're done. You got two games.
Okay. Yeah, I think that'll be fun. And you talked in one of your slides was remapping inputs anyway, so
Yeah.
so I think that'll be good. Jason, I mean Jason. Thinking about Jason. Hey, Jason. Steven, you had some comments there on pooling and vectors and stuff. Did you want to add anything?
No, that would just be it would essentially be the same thing as the pooling, where if you were doing a lot of intermediate vector math and you were making tables, you would hit the garbage collector kind of hard. So it would be the same problem, just in a different form.
Mm-hmm.
But I don't know how it is doing it at the moment.
Yeah. Well, I'm still working up that part. I don't normally use pooling in games. I'm not a big fan of pooling because it requires an additional level of caution with regards to those objects, which I don't like to take. I like to just rely on the system to do the removal for me. So when I have to manage, it's like managing your memory within a thing that manages your memory, which manages your. It's like ad infinitum memory management. I'm like, just get out of here. I don't want to do that.
But you don't normally have hundreds of particles flying around the
Yeah,
screen.
normally I don't have to deal with thousands of particles flying around the screen. Oh, I was going to show the game. Let me show the game. Sorry, I've already got this game coded up. It's not all finished, but I'm going to put it out there for folks so they can see it as it progresses. Let me switch screens here. All right, so this is the game. Let me make it a little bit bigger so we can all see it. What is this? Just drag that over here. So this is way beyond the size of my screen. But as you can see, here's my dude. Here's our basic board so far. There's only one enemy on the screen. And then I can fire in any direction, and I can move and fire as I'm going along. Now, I'm running into a little interesting issue. I've made a mistake in my controller code. So here I'm moving. Then I move my other... There. I move my firing. It's really hard to see. But I'm still pulling to the left with my left joystick, but I've lost my left input. Now, I've either got some kind of bleed over from my device, like the two joysticks are sending out signals that are cross-talking or something, or I've done something wrong. It's probably I've just done something wrong in my code. Let me show you a couple of cool things here while we're at it. I'm going to put more enemies on the screen. Where is it?
That reminds me of the Penguins of Madagascar, where he says, "We've lost engine 1 and engine 2 is no longer on fire."
That's always good. I'm gonna ramp this up to allowing 60 enemies on the screen at the same time. So they start to come in. They're coming after me. Now the counters that you see on the upper left is my particle management system. So I'm caching particles in this example, and the rightmost number is the total number of particles that I have created that may be cached or in use. The left number is the particles in use, and the middle number is the free particles. So, I'm sorry. The first number is the free particles, the second number is the in-use particles, and the third number is the total of those two numbers together. So the total particles that I ever need as I'm flying around is 149, which is pretty good. So I just need to keep 149 cached objects, and I can create this particle trail. But you'll see the problem here in a second is as soon as I start firing, now I'm starting to get significantly more I'm trying not to. Oh, that'd be nice. Yeah, come on, get some. Yeah, so at some point here, I'm starting to encounter some kind of lag. It's really kind of hard to see in the. Here it is. See this lag? Oh, stop it. Okay. So I got up to 1,452 particles. Now I've gotten it way higher than this, but that's about where I'm going to be today, it looks like. I've gotten it up into around 3,000, and that's when I really start to see some issues. And I haven't had the time yet to debug my code and see if it's something I'm doing or if this is purely a limitation. Now, the way these particles work is when you fire, you get an explosion, and it goes through this loop that pulls out previously calculated angles, gets some particles, puts them in the center of the explosion, and then transitions them out based on that angle calculation. So I know that probably didn't make a whole lot of sense, but imagine, if you will, you get an explosion, and then the explosion code goes around from degree 0 to 360 every 4 degrees or so and says, I want a particle shooting out at this angle. I want a particle shooting out at this angle. Look up the number for that I previously calculated, do some math, do a transition, and the particle moves out from the center of the explosion to the end point and then is destroyed. And so what you get is this really nice looking effect. At least I find it kind of nice. It's kind of cool. But the problem is there we go. We just had a bit of a lag. Is when I have hundreds or thousands of transitions going on at the same time, I think I'm running into a performance issue. So I'm going to experiment with doing some of this stuff manually, or another thing I'm thinking about doing is what's the Stephen? What's the it's the approach that people use for threading. It is
coroutines.
Coroutines, yeah. So I may use a coroutine to iterate over the particles. This is one I've been thinking about a lot, is iterate over the current particles that need to move. Use a coroutine, move as many as I can in a coroutine loop, and when I run out of time for that frame, stop moving them. Then I come to the next frame, and I move the remainder.
You could stagger them, too, where you did one and skip a few, do another one, and then slide the window over every frame.
Yeah, I could do that, but I think that if I use this coroutine approach, that it'll do something similar. I'm trying to get my screen back here. Sorry, it's got too much going on. I think if I use the coroutine approach, that will give me, in essence, the same result as skipping, but it'll be more accurate. I don't want to accidentally forget one for like 100 cycles and go, why is there still this particle that hasn't moved? But if I do them all, pause, do more, keep doing them in the time I have, it should visually look correct, but as I get more and more workload, I'll still be able to continue the rest of the operations in the game.
That'll be interesting to see, because that's you're really talking about some ninja foo there.
Yeah, it is kind of ninja foo, but you know, it's in reality, the only ninja foo part of it is the coroutine calls.
Right.
The loop concept is quite simple.
Yeah, right. But still, it's something outside of what you would normally encounter, right? Now you're really.
Yeah, that's why I was really like, yeah, this is kind of cool, because we're really going to have to apply some intelligence to solve this issue with these particles, because there just get to be so many things going on the screen at the same time.
Okay, so going back to the conversation about the game being new or being old, right? I see that there are some similarities between the last game. The last game was a top-down shooter, and it had, I don't know, like what we would call it, boundaries. You know, bounding areas. It had the enemies were doing what do you call that?
Seeking.
Seeking, or what's the term when they? There's a term for it. Well, when they're homing in on the player, right? They're following the player.
Seeking. Seeking is the word you're thinking.
Yeah, I was thinking of pathfinding or whatever, but yeah, and then and then you're moving the player around. And I mean, if you go back and watch the previous videos, and you see that there's an archer, and then there's zombies. Here, there's a ship, and then there's these other things, whatever the enemies coming in to get you. It's pretty much the same overall concept, just different. I don't know, different costumes.
This goes to what we've said before on the show, which is really there's no new mechanics.
All right.
There's a limited number of base mechanics in games. It's just how you apply them aesthetically and tweaks that you give to them so that they seem different.
Yeah.
But they're really fundamentally the same.
Yeah, I was watching a YouTube video over the weekend where this I can't remember the name of the game, but there's this game. It looks like a console game, maybe just a computer game. But you shoot a wire and you connect objects together, and then they get pulled around and slam into each other, and I'm like, well, it's got it's a 3D world, and your player is a 3D model, and you've got all these things that they're going on, but they're the sort of the I don't know, just they're just sort of the filler for this game mechanic, which is really plugging objects together and watching them smash together, and then letting the physics just happen, right? And
I think that's all games, though.
Yeah, well, that's what I'm saying, though. I mean, you really could apply that game mechanic to any kind of game. It could be a 2D game. It could be it could be any kind of. It doesn't have to be like jumping on top of trains or planes or automobiles or whatever and doing it. It could be a simpler form too. I don't know.
Sure.
Just seeing, and I've seen that mechanic repeated in other games, and I don't know. It's just like all of a sudden you're like, wait a minute. The whole thing revolves around this one thing, right? Like when you're doing what's the game? What's the game where you're Assassin's Creed?
Okay.
I mean, Assassin's Creed. The whole mechanic really. I don't know if you want to call it mechanic. I guess the premise is climbing walls.
Yeah.
Right. I mean that's
it. Climbing walls and sliding down stuff and shooting guys.
Yeah, I mean it's oversimplification to say that, but you get my point. Is that now?
Actually, that's the essence of that game.
Well, you see it being pulled into other games like I was playing Halo 5 over the weekend, and now you're like pulling, in Halo 5, you're like pulling yourself up over these ledges and getting up to places that you don't normally get to in the game without flying or doing some other maneuver. But here it felt very Assassin's Creed-like, and I was like, well, there you go.
Just Cause.
Well, Just Cause is the one I'm talking about. Yeah, that's exactly the one I'm talking about. Yeah. Just Cause 3,
that's one of my favorite games, though. They
yeah.
Not to wax on, but man, they really nailed it on Just Cause 2. Are you playing Just Cause 3 or 2?
I didn't play it. I just saw the video for it.
Oh well, Just Cause 3 is like ramped up Just Cause 2. More additions to the mechanic.
Right.
More variations on how you can use the same mechanics that you already had.
Right, but it's still just all about that mechanic, really.
Everything in that game is about grappling hook, flying, and driving things.
Yeah. So, yeah. So anyway, yes. When we're looking at something like that, I'm looking at, like Sudoku. Put a grappling hook in it.
Sudoku with grappling hooks.
That's all I'm saying.
I don't even know how that would work, but
I don't even know. It doesn't matter. Because once you figure that out, right? Once somebody says, "Oh, you know what this is? This is like Sudoku with grappling hooks," right? And then they put it together and they smash it up and they put it out and they do the artwork, high polished artwork or whatever, and then people are like, "Man, this is great! This is the greatest thing ever."
We joke, but I give you 3 months and there will be a game out there, Sudoku with grappling hooks. I don't know how it'll be done, but somebody will do it.
I'm telling you, you heard it here first.
Heard it here first.
All right. Well, I'm looking forward to that. We'll jump into that more. And you said the source code is going to be available, so we're going to put that in the show notes.
I'm going to give you a link right away for today's show, so people can see it early on. But if they check back over the next couple of weeks, they'll see that I'll be committing stuff. So by the time
Okay.
we come around to the next show, everything should be completely functional, less the experiments that we'll do with optimization and stuff like that.
Okay. Hey, I want to say one last shout out to Sergey, who's here on the panel. And congratulations, Sergey. Sergey's joining the Corona team to do to what? What are you going to be doing, Sergey?
I'm gonna work on game tutorials on plugins, and currently I'm updating Ghosts versus Monsters template. If you remember this one, it's been around for a long time, and it doesn't really work anymore. And it uses director class, and yeah, that sort of stuff. I'll be
Is that the Angry Birds clone?
yeah, this one.
Yep. Sweet.
Yeah, and I think we're getting a little bit of echo off of you.
Oh,
But yeah, that's
that's
definitely something that's needed. I know that Raj, one of the things that he wants to do is make sure that anytime somebody goes and pulls a code sample or something, that it's updated and works, and that that's one of the exponential things that we haven't been able to address. Some of these examples have come out over a period of time, period of years, right? Different people have developed them, and then they've been out there, and then we've had graphics 2.0. We went from storyboard director to storyboard to composer, and some of these things need to be updated. So I'm looking forward to seeing that happen and being able to pull all of those examples and repos and everything into a place where people can get to them easily, because I think right now they're a little spread out and it makes it a little confusing to find. But congratulations, yeah, glad to have you on the team.
Thanks. I'm glad to be here as well.
Very cool. All right, well, guys, that's all we have for this week. Happy New Year if you're watching this show before, or even if after. Happy New Year. And we won't, like I said, be back here next Monday, but we'll be back the Monday after, which is probably the second week of January. Until then, have a great week, and happy coding.
Bye.
All right.